I'm going to give you a list of examples here, and what we're going to do is we're going to solve for x. What I want you to notice in these first 4 examples is that we have integers, okay? We have whole positive numbers and whole negative numbers in these set of examples. So we will get a chance to see different kinds of examples for solving for x. So let's start with the very first one. Okay, so we have 2x is equal to 4. To solve for x, we want to isolate x. In order to isolate x, notice that there is a number attached to the x, whereas like I said in part 1, there was not a number attached to the x, so we did not have to use multiplication and division. We needed to use addition and subtraction in that case. Okay, so but in these examples we need to use multiplication and divisions. Okay, so we have a number attached to the x. So 2x is the same as 2 times x. So we need to do the opposite of multiplication because we have a multiplication situation going on. So in order to do the opposite of multiplication, we need to divide both sides by 2. So when we divide both sides by 2, the 2's cancel, okay? And we are left with just a 1x, okay? So now we have a 1x is equal to 4 over 2. Now 1x is just x, right? So we can just get rid of the 1. So I'm just going to rewrite it like this. And 4 divided by 2 is just 2, okay? So there we have the first example. What about the second example? This time we have negative 2x is equal to 4. Well, we want x by itself, right? So I am going to divide both sides by a negative 2. Okay, so a negative divided by a negative is a positive. So again, we have a positive 1x, and we have 4 over negative 2. Again, 1x is just x, so I'm just going to write the x by itself. And 4 divided by a negative 2 is a negative 2. Okay, so there you have it for the first example. Let's go, the second example. So how about 2x is equal to negative 4? So again, so this time we have a negative sign on the right side of the equation, right? So again, I'm going to divide both sides by a positive 2, and the 2's cancel. We left with a 1x, and we have negative 4 over 2. X by itself is just, 1x is just x, and negative 4 divided by a positive 2 is a negative 2. Okay, and let's look at this last one over here. Again, we have a negative number. We want to isolate x. So we're going to divide both sides by a negative 2. The 2's cancel. We're left with a 1x is equal to negative 4 over negative 2, which means we have x, because 1x is just x, right? And so a negative 4 divided by a negative 2 is a positive 2, because a negative divided by a negative is a positive, so that gives us positive 2. Okay, so there you have it for the first 4 examples. Let's look at our next set of examples. Okay, we are moving on to our second set of examples. Notice that in this set of examples, we have a fraction on our right side of the equation, okay? So be very careful here. So teaching this class several times, I'm able to see where my students could have gotten confused a few times. So I am going to do my best to try to show you how to work these problems without making careless errors. Okay, so when I see a fraction, I want to go ahead and make the number attached to the x like a fraction, okay? So before I even start computing, I want to go ahead and just rewrite what I have and give it a denominator of 1. Why am I doing that? Well, 3 divided by 1 is the same as 3. I didn't really change anything. I just rewrote it in a different way. I'm doing that to avoid confusion. We have a fraction here. We want to isolate x. So what we can do is we can multiply both sides by the reciprocal, okay? Because if I try to go ahead and divide by 3, okay, like we did in our first set of problems, we can confuse where we need to multiply on the right-hand side. So to avoid confusion, I like to write it out like this. So keep watching so you can see what I'm talking about. So what I'm going to do is I'm going to multiply both sides of the equation by 1/3. So I do it to the right side, and then now I'm coming over here and I'm doing it to the left side. So notice all I did, I rewrote what I have here. It's right here, but I'm multiplying both sides by 1/3. When I do that, the 3 cancels here, and the 3 cancels here, and we're left with 1x, okay? So we're left with 1x. On this side, we basically have 3 times 1 over 2 times 3, okay? And so now I'm just gonna rewrite 1x as x. Now, you can do one or two things. You can go ahead and see where you can cancel. I can cancel the 3 here and the 3 here, or I can multiply them together and reduce to lowest terms, okay? So since I see where it cancels, I'm just going to go ahead and cancel it out right here. And so we're left with 1/2, okay? So x is equal to 1/2 in this case. Let's look at this situation over here. Again, I'm going to rewrite as 3 over 1x. And what I'm going to do to isolate x, I'm going to multiply both sides by the reciprocal. Remember that, yes, could I have just divided both sides by 3? Yes. But remember, division, anytime that you are dividing, you are in fact multiplying by its reciprocal. We talked about how to add and subtract and multiply and divide fractions. I spoke about that in another video, so you're more than welcome to refreshing your memory on that. I'll leave the link in the description below. Okay, so here we have, I'm going to multiply by the reciprocal. So the reciprocal of -3 over 1 is -1 over 3. So I'm just multiplying both sides by -3 over 1. I'm sorry, by -1/3, okay? Now, a negative times a negative is a positive number, right? The 3's cancel, so we're left with 1x. The 3's cancel here, so we're left with -1/2. And once again, x times 1 is just x, and so we have x is equal to -1/2. Great, so not so bad, right? So let's come over here. And we have, I'm just going to, again, rewrite. And I'm just going to multiply both sides by the reciprocal of 3 over 1, which is 1 over 3. The 3's cancel, so we're left with x is equal to -1/2. Great, okay, so I think you're catching on here. Let's look at our last example here. So I'm just going to rewrite as 3 over 1, as negative 3 over 1x is equal to negative 3 halves. Okay, so now we have a negative number on both sides of the equation. So I'm going to multiply both sides. Okay, let's give it some more room here. I'm going to multiply both sides by a negative 1/3. Sorry if you can't see that. That's a negative 1/3. Coming over here and I'm multiplying by a negative 1/3. So a negative times a negative is a positive, so we're left with a positive 1x. And we have two negative numbers being multiplied together, so that's going to give us a positive number. We also see that the 3's cancel, so we're left with a positive 1/2, which means x is equal to positive 1/2. Okay, so there you have it for our next set of examples. Stay tuned. We need to move on to another set of examples. Here is our last set of examples. I want you to notice the setup here. So we have a fraction this time on the left side of the equation. And remember, with our previous example, we had a fraction on the right side. This time we have a fraction on the left side. And that is true for the first two examples here. For the last two examples, we have a fraction on both sides of the equation. So let's get right into these examples. Again, I am going to rewrite, and I'm going to make both sides look like a fraction. So I'm just going to come here and I'm going to rewrite it out as 2 over 1. Remember, a number divided by 1 is the number, so I really did not change anything here. So to isolate x, we want to multiply by the reciprocal. So I'm going to come over here, let me just come out and rewrite this out. And what I'm going to do is I'm going to rewrite by the reciprocal. So the reciprocal of 1/2 is 2 over 1. So I'm going to come here and I'm going to say 2 over 1. Okay, so now because our goal is to isolate x, so now the 2's cancel and we're left with just 1x. Now here in the numerator, we have 2 times 2 over 1 times 1. Again, 1x is just x, and 2 times 2 is 4, and 1 times 1 is 1. And so we have 4. X equals 4 because 4 divided by 1 is just 4. Okay, so coming over here, let's do the same. First, let me rewrite what we have. I'm rewriting the right side of the equation because we don't want any confusion going on. When I see a fraction, I just want to rewrite all of them as fractions. So I want to isolate x, but before I do, without manipulating the other equation, I'm just rewriting what I see. I'm not changing, so I can show you the steps. So we are multiplying both sides by the reciprocal of 1/2. What is the reciprocal of 1/2? Well, the reciprocal of negative 1/2 is a negative 2 over 1. So I'm going to come here and say negative 2 over 1 on both sides. A negative times a negative is a positive number. So now we are left with 1x is equal to 2 times a negative 2 all over 1 times 1. Again, 1x is just x, so I'm just going to rewrite that as an x. 2 times a negative 2 is a negative 4, and 1 times 1 is just 1. And again, negative 4 divided by 1 is just a negative 4, so I'm just going to rewrite it as negative 4, okay? Moving on to our third example. This time, we have a fraction on both sides. Again, it's already in the form that I like it to be in, so I'm just going to come out and rewrite the number here. And what I'm going to do is I'm going to multiply both sides by the reciprocal of the number that is attached to the x. So the reciprocal of 1/2 is 2 over 1. So I'm gonna come over here. Okay, and we see that the 2's cancel out. So we're left with just 1x. And over here, I'm just going to go ahead and write it out in steps. That means we have 1 times 2 over 2 times 1. Again, 1x is just x. 1 times 2, well, how about we just don't compute it because we can see that the 2's cancel here, right? So we're left with just 1 over 1, and 1 over 1 is just 1. Bam! Okay, now come on over here with our very, very last example. Aren't you glad we're coming to the end? So again, let me just come here and rewrite so that you can see all of the steps. We are multiplying both sides by -2 over 1. And so when we do that, we see that the 2's cancel. I'm going to write it out in steps. How about it's a -2 times a -1 over 1 times 2. And we still carry over our x. And now we have 1 times a -2 all over 2 times 1. That's basically what we've been doing all along. I'm just sort of showing an extra step here. So a -2 can cancel with this 2, but also we have a negative number here. So -2 times a -1 gives us a +2. So that means that we can cancel. How about I just go ahead and write out the steps? So that gives us a +2. And of course, 1 times 2 is 2. Keep our x. 1 times a -2 is a -2. And 2 times 1 is 2. Again, the 2's cancel, which we could have done in this step, but I just kind of wanted to show you like an extra step. Why not? Okay, and then the 2's cancel here. Okay, so now we have 1x is equal to a -1, which means we have x is equal to a -1. There we have it. Thanks for watching. Don't forget to like and subscribe, and don't forget to share this video. Thank you for watching, and you are awesome. Bye-bye.